Now I'd like to take a little bit of time to review some calculus. I'll let your calculus teacher worry about teaching you why these things work, but I'm going to teach you how to do some very basic calculus ideas. So first off, we want to talk about the derivative. If I've got some function of x, I have some function of x, I want to learn to take the derivative of that function, df dx, also sometimes written as simply f primed. Well, let's start with the possibility that it is simply a power of x, that f of x is equal to x to the n. And for now, let's imagine n is an integer. Well then, df dx, we're simply going to take the n and bring it down in front. So we multiply what we get by n. And then it's x to the n minus 1. So let me give you an example. Suppose f of x equals x cubed. Well then, df dx will be, we bring the 3 down in front, 3, x to the 3 minus 1, 3 minus 1 is 2, so this is 3x squared. That's how we take a derivative with respect to x. Now, if instead it was a function of time, so I've got a function of time equal to t to the 5th, and I wanted to take the derivative of f with respect to time, notice I'm taking the derivative relative to time instead of relative to x, so now my time up here is treated just like I treated x before. I bring down the 5, and then it's t to the 5 minus 1, which is 4. Now there are a few specific examples of this that are worth considering. What if I simply have f of x equals x? Well, that is x to the 1, so df dx. I bring down the 1, and then it's x to the 1 minus 1 is 0, so this is 1x to the 0, but anything raised to the 0 power is just 1, so this is in fact simply 1. Well, what if I take a derivative of a constant? Well, if I have f of x equals 1, that's simply x to the 0. And df dx will equal 0 times x to the 0 minus 1 would be negative 1, but it's multiplied by a 0, so it is simply 0. Okay? Now it turns out this power rule works even if it's not an integer power. For example, suppose I have f of x is equal to the square root of x. In this case, this is the same as x to the 1/2 power. In that case, df dx would be 1/2 times x to the 1/2 minus 1. 1/2 minus 1 is negative 1/2, or in other words, this is 1 divided by 2 times the square root of x. Now, what if they are not simply pure powers? For example, what if f of x is equal to 3x squared plus 7x? Well, it turns out when I multiply a power by a number, the derivative of that number is 0. So it doesn't matter. I just keep the number there. And I take the derivative of the function of x. Same thing here. I multiply by the 7, and I take the derivative of the x. Because they're added together, I add together the derivatives. So f primed of x, also known as df dx is equal to 3 times 2x, taking the derivative of the x squared, plus 7, which comes out to 6x plus 7. The way we write these rules is we say that the derivative with respect to x of c f of x plus d g of x is equal to c times the derivative of f with respect to x plus d times the derivative of g with respect to x. In other words, when I add two things together, I just take the derivative of the two parts and add the derivatives. When I multiply a function by a constant, I just multiply the derivative by that constant.